girls, we are now on lesson 5. I hope that all of y'all are doing well on your other math pages, and I hope that you understand the notes that I gave you, and I hope you've been watching the YouTube videos. And today we're going to start with lesson 5, and the title for today is we're going to classify or name rational numbers. So we're going to get into that lesson right now. And we've got 2 vocabulary words today that we're going to talk about that are going to be new to you, that we did not do in the 5th grade. Okay, so the first vocabulary word that we're going to talk about is what a terminating decimal is. Terminating decimal. Okay, now I know that y'all have been over the last couple lessons that y'all have changed your fractions into decimals, correct? So we're going to talk about decimals today, but we're going to talk about a terminating one and then also a repeating decimal. All right, so the terminating decimal, here's the definition for a terminating decimal. It is a decimal number which has a repeating digit of 0. Okay, now that's the definition of a terminating decimal. It's a decimal number which has a repeating digit of 0. Now, let me give you an example as to what I mean by that. So let's say, for instance, that you divided your numerator by your denominator, and you got an answer that looked like this after you divided it. Decimal 62500. So let's say that was the answer that you got, and you look at that and you're like, what? What does that mean? Well, here's the deal. If you look at this decimal number, you see after the 625 that you just keep getting a 0, a 0, a 0. Well, what could you do with all those zeros if you wanted to? You could drop them. That's correct. Now then, do you notice that your number stops? It terminated. It doesn't go any further because if it did keep going, all you would have would be zeros behind it. So we call this a terminating decimal because to terminate something means to stop. So the number actually stops because it would just be keep getting a 0, another 0, another 0 every time you divide it again. So we call this a terminating decimal, which is a decimal number that has a repeating digit of 0. Okay? So that is a terminating decimal. Okay. And you notice you're not going to get a remainder because if you're dividing and you keep putting 0 up here, when you do the 0 times the number, you're going to get 0 again. And it's just going to keep getting 0 and 0 and 0 with no remainder. So you wouldn't have a remainder. Okay? All right. Now let's talk about a repeating decimal. Okay? That's going to be our second word for the day. A repeating decimal. All right. So here's the definition for this one. A decimal whose digits repeat in groups of 1 or more. Okay, now let me explain to you what I mean by that. Okay, so let's say, for instance, that you divided your numerator by the denominator, and you got this as the answer. 3.222. Now, Miss Lynn just stopped it right there, but if I was actually doing this and dividing, I would get another 2, another 2, another 2, and it just keeps going and keeps going and keeps going. Okay? Well, what is repeating in that decimal number is the 2. So the way you're supposed to write that as a final answer is you would make it look like this. You would say, all right, it's 3.2, and you would put a bar on the top, and that tells you that the 2 just keeps going and keeps going and keeps going. So there's no reason to write 3.222222. There's no reason to do that. Just put 3.2, and when you put the bar on top of it, then it's understood. And I know by looking at that really it didn't stop right there, that 2 is just going to keep going. So, and that's why we call it a repeating decimal, because something in the number keeps repeating, okay? Let me give you another example. That's with 1 digit repeating, but let's look at this one. What if we had the number 3.321321321? What if that was your answer when you divide? Well, do I really have to keep sitting there and writing 321, 321, 321? No, not really. You wouldn't have to do that. After you saw what was repeating, you could write the number, the answer, like this. And put the bar over the whole entire 321. Because if you notice, the 321 is what's repeating itself. Not just the 3, not just the 2. Okay, so you would have to put the bar on top of all 3 of those digits to let somebody know that it's the 321 that is repeating itself. So again, we call this a repeating decimal. Now, if you notice, when you divide, you're going to have to carry this out for a while. That means inside the house, you're going to have to keep adding zeros, drop it, divide, add another 0, drop it, divide, add another 0, drop it, and keep it going for a while until you see if anything does repeat. So you can't just do it 2 times and just say, oh, I'm going to stop right there. You may have to carry it out 3, 4, 5, 6 zeros to see if there is anything that repeats. Okay? So here's the difference. On the terminating decimal, you will have a repeating digit of 0, like this. I saw that the 0 kept repeating. We can drop those zeros. The number stops. The answer is 0.625. And like I said, that's called terminating. It stopped. It did not keep going. But a repeating decimal is one where 1 digit might repeat, 2 digits might repeat, 3 digits might repeat. It just depends on the division of the numerator and the denominator after you divide, whether or not how much repeats itself. So like I said, you'll have to add zeros to the back of your number and keep dropping the zeros and dividing to see whether or not it repeats and what repeats. And then like I said, when you draw the bar over it, that lets me know that it's really not just 3.2, it's 3.22222 and so on. On this one, when you drew the bar over the 321, I know that the answer is not really 3.321, it's 3.321, 321, 321. Okay? So that's the difference. Now, you will have something that I put in your notes, and it kind of explains a rational number, a repeating decimal, and a terminating decimal. Then I went ahead and I included in your notes, so you will have that when you get your packet. Okay? All right. Now then, something I want to talk to you about, okay? And I want to go back over this, okay, to make sure you understand. All right. Let's go back to integers for just a minute. If you remember what integers are positive, negative, whole numbers, right? That's what we learned in one of our lessons. That's what integers are. They are positive, they're negative, whole numbers, okay? And 0. Those are all called integers. Now then, we also learned about rational numbers, okay? And rational numbers were anything that you can write as a fraction, okay? So if you'll remember, if you had 0.8, that could be written as 8/10, okay? If you had 4.5, that can be written as 4 5/10, okay? So anything that can be written or expressed as a fraction, okay? is a rational number. So these two things are not the same, and I don't want you to get mixed up. Integers are not written as fractions. Your integers are just positive and negative whole numbers, and the number 0. But your rational numbers are anything that can be written as a fraction. Okay? That's your rational numbers. And if you'll remember, and I think I told you this in one of my lessons, a whole number, to be called a whole number, you must be positive. Okay? You can't be negative. To be a whole number, you can't, if you're going to call me a whole number, you are going to say that it's a positive number. Okay? All right. So let me show you something else that I put in your notes. Okay? So you're going to see this chart right here where it describes to you what the whole numbers are. Then you got integers, and then you got rational numbers. Okay? So if you look at that, if you look at the whole numbers, of course, we know those are whole numbers, and they're all positive. Now we come out some to integers. Remember, integers, they can be positive or negative whole numbers. Then we go to rational numbers. It's anything that can be written as a decimal. Anything that can be written as a fraction. So all of those can be written as fractions or mixed numbers. Okay? So I do want you to pay attention to this chart because it's going to help you when you do your work. Okay. All right, so let's take a look at a couple of examples that I'm going to do for you, just to kind of show you when you start, when I give you the fraction, how you go about working it to decide if it's a terminating decimal or a repeating decimal. Okay? All right, so let's look at this first one. And this is not really hard because y'all have already divided the numerators by the denominators in previous lessons. Okay? It's just now you're adding a little bit of vocabulary with it. All right, so let's take this one, for example. 5/12. Okay, we want to change that to a decimal number. So we're going to read it 5 divided by 12. So here's how I'm going to write it. Divided by 12, and I'm going to go ahead and add 2 zeros just because I'm going to. Okay, if you want to add 3 zeros, 4 zeros, that's up to you. All right, I'm going to bring the decimal up. Can't go into 5. Goes into 50 4 times. 48. Going to subtract. It's going to be 2. Bring down my 0. Goes in there once. That's going to be 12. Going to subtract that. We're going to get 8. Well, folks, right now I haven't decided if it's a repeating or terminating decimal because I don't have enough information. So I'm going to add a 0. I'm going to drop it. My number is 80. I think that's going to be 6 times. And I think that's 72. Well, let's subtract it. I get 8. Well, again, you look at that. You don't have enough information to know whether it's a repeating or terminating decimal. So let's add another 0. How many times is 12 going to 80? 6 times. That's 72 again. Uh-oh. I see what's fixing to happen. Subtract. Get 8. Oh, I'll do it. Add one more 0. I drop it. Look what's going to happen. It's going to go in there 6 times. That's 72. Guess what I'm going to get as a remainder? Again, another 8. Now, is this enough to see what repeats? Yes, it's enough. You see what's repeating. The 6 is repeating. So when I write my answer, I'm not going to put 0.41666. I'm going to come over here and I'm going to write my answer, my final answer, 416 in the bar to tell you that the 6 is repeating. Okay? So like I said, if you were writing your final answer, that would be your final answer. And that is called a repeating decimal. Okay? Now, let's look at another one. Let me just come over here, and let's do 4/18. Well, of course, I'm going to read that as 4 divided by 18. So, let me put that there. Let me add my decimal, and I'm going to go ahead and put 2 zeros. Miss Lane normally puts 2 zeros, but most of the time I do have to add more. All right, so 18 cannot go into 4. Goes into 40 2 times, which is going to be 36. Going to borrow 4. Going to bring down my 0. Okay. How many times will 18 go into 40? 2 times. That's 36. Oh, I think this one's going to be pretty quick. we're going to find out what's happening on him. Okay, I'm going to add another 0 just to be on the safe side. Got 40 again. How many times does it go in? 2 times. 36. And I'm going to get another remainder of 4. Well, folks, I'm going to stop right there because I already see what's repeating. The 2 is repeating in this one. So when I write my final answer, I'm going to put 0.2 with a bar over it to let you know that the 2 is repeating. So that would be the final answer, and that is also a repeating decimal. Okay? All right? Okay, let's do one more. One more. I want to show you one more. All right, let's do 13 over 25, which is going to say 13 divided by 25. And I'm going to go ahead and add my 2 zeros just because that's what I always do. Bring up my decimal. Can't go in. Can't go in. Whoa. How many times does that go in? 5 times, which is going to be 125. Subtract, borrow, 5, 0, 0. I'm going to bring down my 0. Okay, so let's see what's fixing to happen here. How many times is 25 going to 50? 2 times. That's 50. Okay? Well, I'm just going to add a 0. Drop it. Can that go in there? Nope. 0 times. 0 times 25 is 0. Do you notice that you don't get a remainder? There is no remainder on this one. So what do we call that? That's a terminating decimal. It stops. It doesn't repeat. It doesn't keep going. It stops. So when I write this answer, my final answer is just going to be 0.52. I don't need all those zeros behind there. We talked about that in 5th grade that you could drop the zeros. So this answer is 0.52, and it's called a terminating decimal because it stopped. It does not keep going. Okay? So that's the difference between terminating decimals and repeating decimals. The main thing you're going to have to remember, though, is you may have to keep adding several zeros to the back and keep dividing to see if a number repeats or what repeats or if it doesn't repeat. Okay? So keep that in mind. All right, again, I've included the notes in your packet. And then I also have completed the guided practice for you right here.